Yeah, today we will look at the decomposition of a signal into even signal and odd signal. We will try to look at a lot of problems in this, and then by the end of this session you will be able to identify what are the even components and what are the odd components of any given signals. Let us start with the first problem. Let us look at a signal and then we will see how it can be broken into an even signal and an odd signal. We will use all the formulae which you have studied so far, and then we will apply these to our problem, and then we will get a solution. Let us find the even and odd component of the problem x of t, which is an exponential function. X of t is equal to e to the power of jt. And let us start that first. X of t is equal to e to the power of jt. Now this function is given. Now we have to break this into an even component and odd component. So let us write that. So we know x of t can be expressed in terms of xc of t plus xo of t, where if you see this, xc of t is the odd even component and x0 t is the odd component of this signal. And we also know xc of t is given by this formula, half of x of t plus x of minus t. So this will give us the even component. Similarly, the odd component also can be found out. xo of t is equal to half of x of t minus x of minus t. So I repeat, xo of t is equal to half of x of t minus x of minus t. Now using these two formulae, what we will do is we will try to calculate what is the even component of the given function and what is the odd component of the given function. Okay. Now let us first calculate the even component of the signal. Now xc of t is equal to half of, what is our x of t? Our x of t is e to the power of jt. So e to the power of jt plus e to the power of, now here we are saying it is minus t. So t has to be made negative. That means I have to make this negative. So this will become minus jt. Okay. This formula is very familiar. What does it say? It says half of e to the power of jt plus e to the power of minus jt, which is nothing but a cosine function. So this is equal to cos of t. So this is my even component. This is my even component. Now let us calculate similar lines the odd component. Now what is the formula for odd component? x0 of o of t or x of t. I repeat, xo of t is equal to half of x of t minus x of minus t. So this can be written as half. What is our x of t here? Our x of t is e to the power of jt. So this will become e to the power of jt minus e to the power of minus jt. Okay. To get this into the standard format, I will divide and multiply by j. Okay. So I can write this as 1 by 2j into j, 1 by 2j into j e to the power of jt minus e to the power of minus jt. So this is equal to j into sin t. Okay. So given exponential function, the even component as we have found out was x e of t is cos t and x o of t we got it as j sin t. So this will become j sin t. So as you see here, the exponential function is broken into an even component which is a cosine function and an odd component which is a sine function. Let us see another problem. Question number 2. We have to find the even and odd components of this. X of t is equal to sin omega naught t plus pi by 4. Okay. Now again we write what are the formula we know, then we will break it into even component and an odd component. So what we know? We know that a signal x of t can be written in terms of an even component plus an odd component. Now let us calculate the even component. X e of t is equal to half of x of t plus x of minus t. So, what we do here again, as we have done earlier, here t has to be replaced whenever x of minus t comes, t has to be replaced with a minus t. We will do that now. So, let me write here. So, this is equal to half. Now, x of t, replace it with the sine function. So, this will become sine of omega naught t plus pi by 4. Okay. Then comes this, where I have to convert t into minus t. So, this will become omega naught of minus t plus pi by 4. So, sign of minus is minus. So, we will take out the sign here. So, this will become half of sine omega naught t plus pi by 4 plus sine of minus omega naught t plus pi by 4. Next, what we will do is, we will bring out this negative sign outside, and then we will see whether this can be used helpful for us in identifying with any trigonometric identity which we know. Now, x e of t is equal to half sine omega naught t plus pi by 4. So, here it is omega naught minus omega naught t plus pi by 4. Now, this negative sign will bring out. So, this will become half of sine omega naught t plus pi by 4 minus sine omega naught t minus pi by 4. Okay. So, if we look at this formula, this represents sine of a plus b minus sine of a minus b in trigonometry. So, this is equal to 2 cos a sin b. So, then I will write this like this, using that identity we will write this. Here this is a for us and this is b for us. So, it is 2 cos of omega naught t, 2 cos a sin b. So, this will be equal to sin pi by 4. So, this is equal to how much? This is equal to 2 get cancelled. So, this will be 1 by root 2 cos omega naught t. So, this is the even component for the given signal. Now, let us calculate the odd component for this. Okay, we know x of t is equal to half x of t minus x of minus t. Okay. Keeping this notation, we will convert again, given x of t, we will write like this. So, this is equal to half of sine omega naught t plus pi by 4 minus sine minus omega naught t plus pi by 4. Okay, bringing out the sign, negative sign here, I can write like this, half of sine omega naught t plus pi by 4. Then this becomes what? This is minus here. So, this I can write as plus sine omega naught t minus pi by 4. Again, this represents the trigonometric notation, which is equal to sine of a plus b plus sine of a minus b. That will be equal to 2 sine a cos b. So, let us use that formula here and then write it here. So, this will become 2 sine omega naught t into cos pi by 4. So, this will be equal to, here half is also there. So, half. So, this will become 1 by root 2 sine omega naught t. So, this is the odd component of your given signal. So, let us write both of them here, even component, odd component here. We can summarize here, we will write the even component xc of t is equal to 1 by root 2 cos omega naught t, and odd component x of t is equal to 1 by root 2 sin omega naught t. So, this is the answer solution where we have calculated both the even component and the odd component. Let us look at a third problem, which is x of t is equal to cos t plus sin t plus sin t cos t. So, we will calculate the even and odd components of this train of signals. Question number 3, x of t is equal to cos t plus sin t plus product of cos t and sin t. Now, given such a sequence of signals, we have to calculate again what is the even function of this whole thing and the odd function of the whole thing. Okay. So, let us start with the even function now. So, we know xc of t is equal to half of x of t plus x of minus t. Okay. Let us apply this here. So, what is this? First, let us write here cos t plus sin t as it is plus cos t sin t as it is, because this is our, this whole thing is our x of t. Now, x of minus t will be cos of minus t plus sin of minus t plus cos of minus t sin of minus t. So, cos of minus theta is cos theta, sin of minus theta is minus sin theta. Remembering that formula, let us discuss this again here. So, I will write this as half of cos t plus sin t plus cos t sin t. Okay. This all this is our x of t, the whole thing is x of t, plus cos of minus t is how much? Cos t, sin of minus t is minus sin t, and this is cos of minus t is cos t, sin of minus t is minus sin t. So, this will become minus cos t sin t. Okay. So, then we will cancel this, this is getting cancelled with this and this is getting cancelled with this. So, the ultimate answer is half of 2 cos t. So, this is nothing but equal to cos of t. That means, given x cos signal, sin signal and cos t sin t signal, the even component of this is nothing but cos t. Now, let us calculate the odd component of this. Now, let us calculate the odd component. We know x of t is equal to half of x of t minus x of minus t. Let us put this here. So, this is equal to half of cos t plus sin t plus cos t sin t. Okay. Minus what is it I have to do now? Cos of minus t plus sin of minus t plus cos of minus t sin of minus t. Okay. The whole thing we will put in a bracket. Now, this is equal to half of cos t plus sin t plus cos t sin t. Okay. This is cos t. So, minus of minus will be minus, we will open this bracket. So, this will become cos t minus cos t. So, this is sin of minus t. So, it will become plus sin t and this will also become plus. So, this will be cos t sin t. Now, we can cancel these two and this will become half of 2 sin t plus 2 cos t sin t, and this is equal to sin t plus cos t sin t. So, this is our odd components. So, let us summarize them, let us write both of them together. So, what is x e of t we got? Got this as a cos t, and then the odd component x of t we got it as sin t plus cos t sin t. Now, we will look at the fourth problem, where we will try to calculate again the even and odd components. All these problems will help us in finding solution to any given problem. So, x of t we are talking about 1 plus t cube multiplied by a cos function. We will look at that now and then we will solve that problem. Now, this is question number 4. X of t is given as 1 plus t cube cos cube 10t. So, let us solve this fourth problem. Cos of x of t is equal to 1 plus t cube cos cube of 10t. Okay. Again we will calculate the even component of this, which is again we will write the formula. What is that? Half of x of t plus x of minus t. Now, x of t means we have to repeat this as it is here. So, that will become half of 1 plus t cube cos cube of 10t plus, now we have to replace t with minus t. So, this will become plus of let us say 1 plus minus t whole cube, okay, into cos cube of 10 of minus t, okay, whole again we have to put a flower bracket here. So, now this I can write as half of 1 plus t cube cos cube 10t. Okay. Now, if you look at this, this is minus t cube. So, this will be 1 minus t cube, cos of minus theta is always cos theta, into cos cube of 10t. Now, we will expand the brackets. So, this will become half of cos cube 10t plus t cube cos cube 10t plus cos cube 10t minus t cube cos cube 10t. So, if you see this and this gets cancelled and this is 2. So, the even component is equal to cos cube of 10t. This is the even component of the given signal. Now, let us calculate the odd component. So, odd component x 0 of t is how much? Half of x of t minus half of minus t. So, let us expand this. So, this will become now half of, the first part remains same. So, it will be 1 plus t cube cos cube 10t, okay. Then minus, we have to calculate for this. So, this will become now, I will put a flower bracket here. So, this will become 1 minus t cube and then cos cube 10 of t minus, isn't it. So, this will be cos cube of 10t. Now, this is negative here. So, we will open this bracket, we can write like this, half of cos cube of 10t plus t cube cos cube 10t minus cos cube 10t plus t cube cos cube 10t. Now, removing these terms, I will get this is equal to t cube cos cube 10t. So, this is the odd component of a signal. So, we have also calculated the even component. Earlier the even component was simple cos cube. Now, sine component is t cube of cos. Okay. So, these are the two different signals. One is an even signal, which an odd signal, which you got from a given signal. Now, let us solve the fifth problem in this series, where we have again a series of equations given like 1 plus t cube like that. That equation we will solve now. Let us solve this fifth problem of the series. This is the problem given. This is the fifth problem in the series, where you have an x of t is equal to 1 plus t plus 3t square plus 5t cube plus 94. We have to calculate what are the different even components present in this signal. We have to calculate how many different components which are even in this signal and which are odd in this signal. Okay. So, let us again start calculating with the even signals. Now, x e of t is equal to half of x of t plus x of minus t. So, let us break this again. So, this will be half of x of t as it is, I will write here. So, this will be 1 plus t plus 3t square plus 5 t cube plus 9 t to the power 4. So, this we will put it here, and then plus where minus t is replaced by minus t. So, this will become plus 1 minus t plus 3 into minus t whole square plus 5 into minus t whole cube plus 9 into minus t whole to the power of 4. Now, we will expand the series. I will get like this. So, this will be equal to half of 1 plus t plus 3t square plus 5t cube plus 9t 4. Okay. Plus this one will become how much now? 1 minus t, this is plus. So, this will become 3t square minus, this will become 3t square, 1 minus t plus 3t square minus 5t cube plus 9t to the power of 4. So, now we will add this. So, I will get like this. So, this is half of 1 plus t plus 3t square plus 5t cube plus 9t 4, okay, plus 1 minus t plus 3t square minus 5t cube plus 9t to the power of 4. Okay. Now, if you see, we can add this. So, this will lose, this is gone, this is also not there now. So, I will get this as 1 plus 1 2, 2 plus 6t square plus 18t to the power 4. So, it will be a simple 1 plus 3t square plus 9t to the power 4. So, this is our even component of the signal. So, even component of the given signal is 1 plus 3t square plus 9t to the power 4. So, this is the given signal. Now, let us similarly calculate the odd component of the sequence. Let us calculate the odd component. X o of t is equal to half of x of t minus x of minus t. So, this will give me the odd components. So, let us again calculate here half x of t, write as it is, what is there, 1 plus t plus 3t square plus 5t cube plus 9t to the power of 4. Okay. So, this is the x component. Now, we will write the x of minus t component. So, x of minus t component is 1 minus t plus 3t square minus 5t cube plus 94. Okay, after calculating, this is what we got. So, this is minus t, so this is minus of minus plus, this is 5t cube, so it is minus 5, this is plus, this is plus. Okay. Now, let us subtract this. So, this you will get as half of 1 plus t plus 3t square plus 5t cube plus 94 minus 1 plus t minus 3t square plus 5t cube minus 94. Okay. Now, this gets cancelled, this gets cancelled, and this gets cancelled. So, the odd components are half of 2t plus 10t cube. Now, this will become half of 2t plus 10t cube. Now, this is equal to t plus 5t cube. This is the odd component of the given signal. Now, we will try to calculate or find out whether a given signal is periodic or not periodic. If it is periodic, what is the time period of that signal? So, that will be our session will go like this, where we will try to take a signal and analyze whether it is a periodic signal or non-periodic signal. Then we will try to find out what is the time period if the signal is periodic. Okay. Let us start off with one simple problem where I will take a complex signal and then we will try to find out what is the period of the signal and what is the condition for periodicity. Okay. So, let us start the first problem. Now, the given signal is exponential signal x of t is equal to e to the power of j omega naught t. Now, we have to calculate whether this signal is periodic or not, or if it is periodic, what is the condition for periodicity. Okay. So, first of all, let us see what is the condition for periodicity. A signal is said to be periodic if we satisfy this equation. So, we have to satisfy this equation where this x of t plus t is equal to x of t. When this is satisfied only, then the signal is said to be periodic. Okay. So, this is the condition for periodicity. So, we will write this here. So, this is the condition for periodicity. So, we have to remember this. This is a very important formula. X of t plus t must be equal to x of t is the condition for periodicity. Now, let us apply this rule here. So, what is our x of t here? X of t is equal to this much. Now, we will write what is x of t plus t. So, x of t plus t for us is equal to how much? E to the power of j omega naught into t plus t. And for the condition to be satisfied, this must be equal to our x of t, which is nothing but the given function, which is e to the power of j omega naught t. So, let us write this here. So, this will be like this. Now, this will be e, let us expand this, j omega naught t into e to the power of j omega naught, the time period capital T, is equal to e to the power of j omega naught t. Okay. That is, what is this? This means this is equal to e to the power of j omega naught t is equal to 1. Let us put this equation as 1. So, e to the power of j omega naught t must be equal. So, we have to calculate for what values of omega naught you will get the values of 1. So, there are two cases here. The case 1 is where omega naught can take a value which is equal to 0, or we can take a value omega naught which is not equal to 0. So, let us analyze those two cases here. Okay. So, e to the power of j omega naught t, this is equal to 1. This is the first equation. Now, let us take case 1 here. Case 1, what is it case 1? Where omega naught takes a value of 0. Then this equation is satisfied, yes, isn't it? So, equation 1 is now satisfied. Okay. Let us take another case where omega naught is not equal to 0. So, case 2, where omega naught is not equal to 0. Then e to the power of j omega naught t is equal to 1 can be satisfied only under this condition. What is that condition? Omega naught t must be equal to m into 2 pi, where m is any positive integer. Okay. So, this condition will be must be satisfied. That means, omega naught t must be equal to m into 2 pi, then only e to the power of j omega naught t will become 1. Okay. So, now from this, what is omega naught t? Omega naught t is equal to 2 pi m, we said, and where m is a positive integer, it is a positive integer. So, what is t here from this? From this I can calculate t is equal to 2 pi m by omega naught. Now, taking the fundamental period, how do I get the fundamental period? I will get the fundamental period when m is equal to 1. So, fundamental period will represented by letter t naught. So, that will be equal to 2 pi by omega naught. Okay. So, the given signal, which is an exponential signal, will be periodic if it is satisfying this condition omega naught t is equal to pi m, when omega naught is not equal to 0, and the time period, fundamental period, is equal to 2 pi by omega naught. So, in the case of omega naught is 0, it is definitely satisfying with a arbitrary time period of 1. Okay. Here, this is the fundamental time period when omega naught is not equal to 0. So, the given signal is periodic provided we satisfy these two conditions. Okay. Now, let us calculate the time period of again a given signal. Here also we will try to find out what are the conditions under which this becomes periodic. Okay. It is a cos signal. So, what is the cos signal? Question second. Question number 2, x of t is equal to cos omega naught t plus theta. What is the condition for periodicity? We have written earlier. So, let us write it again. What is the condition for periodicity? For periodicity, what is that? X of t plus t must be equal to x of t. We remembered this. Now, let us write that same thing here. So, for us, what is x of t plus t is cos. Cos of omega naught into t plus theta, whole thing must be equal to cos of omega naught t plus theta. So, expanding this, so what I will get? Cos of omega naught t plus omega naught t, capital T, plus theta. This is equal to cos of omega naught into t plus theta. Okay. So, for this condition to be satisfied, then this omega naught t must be equal to omega naught t must be equal to again 2 pi m, where what is m here? M is again a positive integer. So, from this you can calculate what is t. T is equal to 2 pi m by omega naught, and the fundamental period t naught is given by 2 pi by omega naught. So, this is the time period of the given signal. The two problems which you have seen earlier, both of them are based on some arbitrary values. Now, let us analyze for the periodicity of a signal by taking some specific values. The 5 problems which we are going to see from now will have specific values, and from which we will calculate the specific time period of the given signal. Let us start with the first problem in this particular series. Okay. Let us see the first problem in this series. X of t is given as sine of 15 pi t. Now, we have to calculate the time period of this signal. Okay. When you will calculate the time period, first we have to satisfy that this signal is in fact a periodic signal. Once you satisfy that this signal is a periodic signal, then we will calculate the time period of this. Now, let us look at this problem. Let us look at this problem, and this problem represents, this is in the form of sine of omega t, okay, where what is our omega here? 15 pi, okay, sine omega naught t. This is of the form sin omega naught t, and omega naught is equal to 15 pi. Okay. So, what is t from this? You can calculate. T is equal to 2 pi by omega. So, this is equal to t is equal to 2 pi by omega naught, this is equal to 2 pi by 15 pi. So, this will be equal to 2 by 15 seconds. So, this is the time period. Now, we have to prove that this is in fact a periodic signal. Okay. So, what is the condition for periodicity which we have seen? We said the condition of periodicity is x of t plus t must be equal to x of t. So, let us see this sine of 15 pi into t plus t. So, this will be equal to sine 15 pi into t plus 15 pi into what is our t value here? 2 by 15. 2 by 15. So, that will be equal to how much? Sine of 15 pi t plus 15, this cancels, this will be 2 pi. Okay, from trigonometry we know that this is equal to what is this value? This value is nothing but this. So, this is equal to again what? This is x of t. So, we have started with x t of t and proved that this x t of t is equal to x of t. Okay. So, this is a periodic signal, but what is the time period of this signal? Fundamental time period of this signal is how much? T is equal to, or t naught is equal to 2 by 15 seconds. So, this is the formula. So, what is the flow which we have done? We have taken a given signal, then we have found out what is the condition for the periodicity, then from that we have taken x of t plus t, then in fact we have proved that this is equal to this, and then we also calculated what is the time period, which is nothing but 2 by 15 seconds. Now, let us see the second problem. X of t is given as cos of root 2 pi of t. Again this resembles what? Cos of omega t. So, what is omega here? Omega here is root 2 pi. Okay. What is t from this? T is equal to 2 pi by omega. So, this will be equal to 2 pi by root 2 pi. So, this is equal to root 2, that is equal to 1.414 seconds. Now, we will calculate whether this signal is in fact periodic or not. Okay, let us see the periodicity. Now, what is the condition for periodicity? The condition for periodicity says x of t plus t must be equal to x of t. Let us calculate x of t plus t here. So, how much is that? That is equal to cos of root 2 pi into t plus t. So, this is equal to how much? Cos root 2 pi t. Okay. Then what is our t here? Our t is root 2. So, this will become root 2 pi into root 2. So, this is equal to cos of root 2 pi t plus root 2 into root 2 is 2. So, this will become 2 pi. So, this is nothing but equal to cos of root 2 pi into t. As you are aware, this is nothing but our x of t. So, x of t plus t is equal to x of t. So, this is a periodic signal. This is a periodic signal. What is the time period? Time period we have calculated, where t is equal to 1.414 seconds. So, this is the second problem. Now, we will see the third problem in the series. Let us look at a third problem, a to the power of j omega t plus theta. Here what is t here? Here t is equal to 2 pi by omega. Now the condition of periodicity we will take. What is the condition for periodicity? X of t plus t, we have to prove it as x of t. So let us take x of t plus t. So how much is this? This is a e to the power of j omega into t plus theta. Okay. So how much is this? This is equal to a to the power of j omega t plus omega into 2 pi by omega plus theta. So this will be equal to a to the power of j omega t plus 2 pi plus theta. Now let us expand this. So this will be equal to e to the power of j omega t a to the power of j 2 pi into a e to the power of j to theta. Now what is the value of this? So this is e to the power of j 2 pi is equal to cos 2 pi plus j sin 2 pi. Cos 2 pi is 1, sin 2 pi is 0. So this value is nothing but equal to 1. So what is this equal to now? So this will again be equal to a exponential of j omega t plus theta. So what is this? This is nothing but our x of t. So this is equal to x of t. So this again is a periodic signal. Okay. So we have proved this as a periodic signal, and the time period for this is t is equal to 2 pi by omega. So even this is a periodic signal. Now let us look at the fourth problem. Again exponential signal, but it is the particular values. Now we have to calculate the time period for this, and we have to establish that this is in fact a periodic signal. Okay. Now this is of the form e to the power of j omega t. So what is omega here? Omega is nothing but omega is equal to 2 pi, and we know what is t? T is equal to 2 pi by omega. So this is 2 pi by 2 pi. So this is equal to 1 second. So this is the time period of our signal. Now we have to prove that this is periodic. So let us see. So what is the condition for periodicity? X of t plus t must be equal to x of t. We will prove that. Now x of t plus t is nothing but exponential of j 2 pi into t plus t. So this I can write this as e to the power of j 2 pi into t plus what is a t for us? Here it is 1. So this is nothing but e to the power of j 2 pi t into e to the power of j 2 pi. So this is again equal to 1. So this is equal to e to the power of j 2 pi t, which is nothing but our x of t. So we started by discussing x of t plus t, then we have proved that x of t plus t is nothing but equal to x of t. So this is again a periodic signal and with a period of 1 second. So this has been proved. This exponential signal is in fact periodic. Let us look at the fifth problem, which is x of t is equal to 2 cos 10 pi t plus pi by 6. Now we have to find out what is the omega for this. Then we have to establish that this is periodic, if at all it is periodic. Now what is omega from this? Omega from this is equal to 10 pi. So t is equal to how much? 2 pi by omega. So this will be equal to 2 pi divided by 10 pi. So this is equal to 2 by 10, that is 0.2 seconds. Now we will take the condition for periodicity and is in fact establish that this is a periodic aspect. So what is x of t plus t now? X of t plus t is equal to 2 cos 10 pi into t plus t plus pi by 6. Okay. So this is equal to 2 cos of 10 pi into t plus what is 10, what is t here? It is equal to 2 by 10. So, this is equal to 2 by 10 plus pi by 6. So, this is nothing but 2 cos 10 pi t plus 2 pi plus pi by 6. So, this is cos of 360. So, this will be equal to 2 cos 10 pi t plus pi by 6. So, this is nothing but equal to x of t. So, the condition for periodicity has been established. We have taken x of t with a certain period t here, which is we have calculated as 2 by 10 or 0.2 seconds. Then we have proved that this is in fact equal to x of t. So, the given signal is periodic with a time period equal to 0.2 seconds.